In this video, I'm going to be talking about how to solve trigonometric equations. Okay, this is part one of maybe a few part series, so we're going to start easy in this episode, and then we're going to make it a lot harder throughout the next few videos. So the first question is this: solve for cos x when it's equal to square root 2 over 2 over this domain here. And the reason why I've given a domain is because angles repeat themselves infinitely. So if they repeat themselves infinitely, that means every single trigonometric equation should have infinite solutions. So that's why I've just capped it off at this domain to say we don't really care about every single solution. Let's just find the ones between 0 and 2 pi. So here's how we do this. If we want to solve cos of the angle x equals square root 2 over 2, let us first work out the angle in the first quadrant for which this statement is true. So what angle in the first quadrant of that unit circle makes it such that the cos of that angle is root 2 over 2? Well, if you said that angle was 45 degrees, you would be absolutely correct. So our first solution to this equation will be 45 degrees, or just pi over 4 radians. But you would notice that over this domain here, between 0 and 2 pi, there are actually two quadrants for which cos of x is a positive integer. You would notice that A, S, T, C, add sugar to coffee. You would notice that it's actually in the fourth quadrant where cos is positive as well. So we already know in the first quadrant, the angle of pi on 4 works. So that would be called our reference angle. Our reference angle is also used in the fourth quadrant. So with the x-axis, we make an angle where it's pi on 4. And what is this angle when we read it in the counterclockwise direction from the x-axis? Well, when we read it in the counterclockwise direction from the x-axis, what we can see it as is this is the same as 315 degrees. And that's just the same thing as 7 pi over 4. So our next solution is 7 pi over 4. And 0 to 2 pi is the same as just 0 to 360 degrees. So those are all the solutions that we can find in our first revolution of this unit circle. Our next question is this: solve for when sine of x equals negative a half, and this time the domain is between minus pi and pi. So first thing we're going to do, again, we need to work out the reference angle in the first quadrant, for which sine of that angle will give us positive a half. Now I know the question says solve for when it's negative a half. We will worry about that in due course. But first of all, what angle in the first quadrant makes the sine of that angle equal to a half? Well, the sine of 30 degrees is equal to a half. In other words, the sine of pi on 6. Okay, so that's our solution in the first quadrant, and that's when it's equal to positive a half. Do we care about positive or negative? Well, we care about negative. Clearly, in the question it says negative. So we have our reference angle is pi on 6, because that's what we get in the first quadrant. But which quadrants is sine actually positive in? Oh, sorry, in this case, which quadrant is sine negative in? Well, the sine of any angle is negative always in the fourth quadrant as well as in the third quadrant. So what we can do is we can draw two reference angles with the x-axis. The first one, we can draw it in the third quadrant. The second one, we can draw it in the fourth quadrant. And we know both of these angles here will be a reference angle of pi on 6 and pi on 6. So how can we work out what angle we actually have if our domain is this? Well, we know our domain is explicitly telling us we can only go between 0 to pi and 0 to minus pi. We can't go all the way around here and say that this angle here is actually 210 degrees, because that would be over our boundary. So we're going to go in this direction, in the negative direction of our unit circle. So if we go in this direction here, we can say that this angle here, because it's 30 degrees, we can say it's negative 30 because we're going clockwise. So our first solution to this question is x equals negative 30 degrees. Or in other words, because the question is in radians, we'll leave it in radians, negative pi on 6. And then we also have our second solution over here, okay, where this angle here is also 30 degrees. So then how can we work out what the angle from the x-axis is? Well, because we're going clockwise like this, the angle will still be negative. And because it's negative, we can say it's negative 150 degrees, which is the same as negative 5 pi on 6. And that is how we have solved the equations for this question here, while maintaining the integrity of our domain. Okay, our next question is this. We need to solve for when 3 tan theta take 3 is equal to 0. This time our domain's a little bit bigger. It's between 0 and 4 pi. So if you want to solve a question where the domain's between 0 and 4 pi, that just means 2 revolutions. So instead of just 2 solutions, we should have 4 in this case. So let's actually solve it. First thing we're going to do is it's much easier to interpret this question if we actually isolate for the tan of theta. So if we isolate for tan theta, this is what we get. We get 3 tan theta equals to 3 by just adding 3 to both sides. And then what we can do is we can just divide both sides by 3. So that means tan of theta equals to 3 divided by 3. And that's just the same as 1. And our domain still stays the same. It's between 0 and 4 pi. So now that we have this, what angle in the first quadrant of our unit circle makes tan of that angle equal to 1? So if we draw out a unit circle for the billionth time, okay, this is our unit circle, we need to work out the angle in the first quadrant, which makes the tan of that angle equal to 1. Okay, so what angle is this? Well, if you said 45 degrees or pi on 4 radians, you'd be absolutely correct. Okay, the tan of pi on 4 in the first quadrant is what gives us 1. So now that we have this, we have the tan of pi on 4 equals to 1. That's our first solution. Okay, in this case, it's not x. We want theta to be between 0 and pi on 4. So theta equals to pi on 4. What other quadrant is tan positive in? Add sugar to coffee. In the third quadrant. In this quadrant, tan is also a positive value. So our reference angle we already worked out with the x-axis was pi on 4. So what is this angle if we read it from the positive x-axis? That would simply be just pi plus pi on 4, which is the same as 5 pi on 4. So our next solution for this equation is pi on 4 and 5 pi on 4. Okay, so normally these would be the only 2 solutions we need to worry about. But now what we need to worry about is the other 2 solutions, because it's revolutions of 2 times. We're going all the way around 2 pi and then 2 pi again. There'll be 2 more solutions. Not to worry, the easy way we can do this is just add 2 pi to both of these solutions. Because if I have a look here, in the first quadrant, I have a solution at 4 pi on 4. We also know that the same solution should exist 360 degrees all the way around, because it's the exact same angle. Even if we add 360 degrees, it's still going to be the same angle, just expressed a little differently. So another way of adding 360 degrees is simply just adding 2 pi. So let's add 2 pi to both of these solutions. Adding 2 pi to a fraction where it's divided by 4 is the same as adding 8 pi divided by 4. So we can really just add 8 pi to the denominators. So our next 2 solutions will be 9 pi on 4 as well as 13 pi on 4. And if you notice, all 4 of these solutions are still within 0 and 4 pi. This is our next question. So we have minus 2 cos of 2 theta equals to square root of 3. And a very big difference between the previous questions and this one is the angle itself. We can see that the angle now, instead of being just x or just theta, I made the same mistake here with the domain, it should actually be theta. Okay, instead of saying just theta or x, I've just said 2 theta. Okay, so most people think you just have to times all your solutions to this equation by 2. That is in fact not what you do. What we have to do in this case is we actually have to adjust our domain first. So even though we're saying that x, or in this case theta, must be between 0 and 360, what would 2 theta have to be between? Well, 2 theta would simply have to be between 0 and 720. And I worked that out by simply just timesing all of our bounds by 2. So we need to solve this equation for 2 theta first. And in the process of solving for 2 theta, the domain will be between 0 and 720. This way, when we actually work out what are our solutions for theta, it'll still be in our domain. It'll still be within the domain of 0 to 360. So let's first isolate this entire equation for the cosine of 2 theta. When we're isolating for the cosine of 2 theta, we can see that cosine 2 theta is simply equal to minus root 3 over 2, just by dividing both sides by negative 2. And what angle in the first quadrant makes cos of that angle equals to square root 3 over 2. Okay, and if you've memorized your exact values, you should know that the cosine of 30 degrees equals to the square root of 3 over 2. So our first solution in the first quadrant, will be 30 degrees. But we know that we want to solve for when cos is a negative solution. We know that cosine is negative in both the second quadrant as well as in the third quadrant. So now when we solve this equation, we have a reference angle in both these quadrants of 30 degrees. But what is the actual angle when we read it from the positive x-axis? So I'll do it again. 30 degrees here, 30 degrees here. Okay, what is the actual angle when we read it from the positive x-axis? So what is this angle here? Well, that would simply just be 150 degrees. And then what would this angle here be from all the way around to the third quadrant? That would be 180 plus 30, which is 210 degrees. So far, these are our two solutions, 150 and 210. So 2 theta is equal to 150 degrees and 210 degrees. But we still have to keep going because we are saying to solve 2 theta between 0 and 720. Okay, so when we keep going, that just means do another revolution around the unit circle. So in the process of doing another revolution, here's what that looks like. We have a solution here and here where the reference angle is 30 degrees. Okay, we already identified that this angle here was 150 degrees and this one here was 210 degrees. But can't we just go 360 degrees all the way around again to say that this angle will also be 210 plus 360? And can't we do the same thing with our 150 degree solution where we just go all the way around back to the start? We can just say add another 360 degrees to our solution and that would still work. Well, absolutely we can. So we can add 360 to both of these and say that 360 plus 150, that is the same as 510 degrees. And then 360 plus 210 degrees, we can also say is the same as 560 degrees. So sorry, 70 degrees. So these are our 4 solutions for which, all I did was add 360. So here's our 4 solutions for which 2 theta lies between 0 and 720. This is the answer to our question. No, it's not. We still need to just solve for theta. No one cares about what 2 theta is. We want to just solve for theta. So in the process of solving for theta, how do we get rid of this 2? Well, we can divide both sides by 2. Okay, so that's exactly what we're going to do. We're going to divide both sides by 2 to get that theta is the same as all of these numbers, just divided by 2. So 150 divided by 2 would be 75 degrees. We have 210 divided by 2 is 105 degrees. 510 divided by 2 is 255 degrees. And 570 divided by 2 is the same as 285 degrees. Okay, our next question is this one here. Minus square root 3 tan of a third theta equals to 3, and we're still solving it for between 0 and 2 pi. So how would we go about this? Well, first we would need to adjust our domain, okay, because we're here solving for a third theta, but our domain is only reflecting normal theta. So what we would do is we would times everything in our domain by a third. So 0 is less than or equal to a third of theta, which is less than or equal to 2 pi over 3. So now what we can do is we can solve this question normally. So the first thing we would do is isolate this question for tan of a third theta. So to do this, we would divide both sides of our equation. We would divide both sides of our equation by minus square root 3. Okay, by minus square root 3. And then what we would get is minus 3 on square root 3. Now when we rationalize this, i.e. we times the top and bottom by square root 3, what we end up having is that tan of a third theta is simply equal to minus 3 root 3 divided by 3. And that would just simplify down to minus square root 3. So now our goal is to solve this question, tan of a third theta equals to minus root 3 between this domain. What is the reference angle in the first quadrant that allows tan of that angle to equal to root 3? So if I have a unit circle like following, okay, in the first quadrant, what value of tan gives you root of 3? If you said pi on 3 and you've memorized your exact values, that's good. Okay, so pi on 3 would be absolutely the correct angle. But we're asking to solve for minus the square root of 3. Here, tan of pi on 3 is equal to positive square root 3. So which quadrants on the unit circle is tan negative in? Well, those two quadrants will be the second quadrant, where sine is the only one that's positive, and in the fourth quadrant, where cos is the only one that's positive. In other words, it's negative for tan in these two quadrants. So now that we've identified that our reference angle is pi on 3, let us now work out the angles that are in the second and fourth quadrant. So in the second quadrant, what we can work out is this is our reference angle. It's still pi on 3 as our reference angle. But what it is from the x-axis, like this, is 2 pi on 3. Okay, so we're going to say that one of the solutions to a third of theta is 2 pi over 3. And the other solution would be in the fourth quadrant, like this, where our reference angle is also pi on 3. And this angle all the way from the x-axis like this is simply the same as 5 pi on 3. However, so even though we have both these angles here lying within the original domain of the question, a third of theta is what we're solving for currently, and a third of theta can only be between 0 and 2 pi on 3. So that means we would actually have to reject this second solution here and just stick with 2 pi on 3. So now that we have a third of theta equals to 2 pi on 3, let us now finish solving it. We times both sides by 3 to get that theta equals to 2 pi. And that is how you solve trigonometric equations.